A public school teacher was arrested today while trying to board a flight at Kennedy Airport. He was carrying a compass, a ruler, and a protractor. Apparently, he's a member of the notorious Algebraic movement, and he was carrying weapons of math instruction. And that's what we will be trying to do today, is do some math instruction with some algebraic tools, but we will be worrying more about properties of equality and properties of congruence. So let's start with proof. Proof, again, is a form of deductive reasoning. And each step in an algebraic proof should have a property or a definition listed explaining why you could make that step. Now, you've actually been using these properties all along to solve equations. You just haven't been listing them. So now we're going to actually start listing the properties. So two of the simple properties, and you know these. The addition property of equality says, well, if A is equal to B, then A plus C must equal B plus C. So I can basically, this is a property that says I can add the same thing to the both sides of an equation. If A equals B, I can add C to both sides. The subtraction property of equality works the same way. If A equals B, then A minus C equals B minus C. Adding or subtracting the same thing to both sides of an equation will still keep both sides equal. Multiplication works similarly. So if I have A equals B, that's my starting equation, and I decide to multiply one side by C, as long as I multiply the other side by the same thing, I can maintain this equality. All right, so the division property also works like that. The division property of equality, if I have A equals B, if I divide one side by C, I also want to divide the other side by C. So multiplying or dividing both sides of an equation by the same thing will still keep both sides equal. All right, so both sides are equal. I have to fill that in because it got chopped off. Okay. So there's still some other properties. One of the really interesting ones is called the reflexive property of equality. And that is like you can say A equals A. Now you're probably going, why in the world would you want to do that? And believe it or not, when we're doing some of our proofs with triangle properties later and looking at sides, we're going to use the reflexive property quite a bit because we'll have to say something is congruent to itself. The symmetric property says, well, if A equals B, then B should equal A. You can switch both sides of the equation, and it will still be equal. We also have the transitive property of equality. This is rather interesting. It's kind of like our transitive reasoning. If A equals B and B equals C, I can skip straight from A to C and say A equals C. All right? The substitution property of equality says if A equals B, then B can be substituted for A in any expression. So transitive, we skip if A equals B and B equals C, then A equals C. Substitution means if two things are equal, I can replace one with the other. So, and don't forget one of my favorite properties of all time, the distributive property. Basically, one of my favorite ways to look at this is I have A of ABs and ACs. So I have A times B plus A times C. Remember, this just tells you how many of the parentheses groups you have. And then you can break it up individually if you need to. So let's take a look at an example. We want to solve the equation 4m minus 8 equals negative 12. So I'm going to show this as an algebraic proof. First of all, 4m minus 8 equals negative 12 is given. That's part of my problem. So that's the problem I'm trying to solve. So the first thing you're probably thinking you can do is add 8 to both sides. And you would be right. That is using the addition property of equality. Notice how I use this sort of shorthand for the properties. That's fine. So 4m minus 8 equals negative 12. Add 8 to both sides. And I get 4m equals negative 4. Then I can use the division property of equality to divide both sides by 4, and my answer is m equals negative 1. We also have properties of congruence. They're very similar to equality properties. Remember, equality tends to talk about numbers like 5 or 6. Congruence refers more to size and shape. So two things have to have the same shape and the same size to be congruent. The reflexive property of congruence is like the reflexive property of equality. Figure A is congruent to figure A. You can always say that something is congruent to itself. We also have the symmetric property of congruence. So it's the same thing. You can switch both sides and it's still congruent. I can have figure A is congruent to figure B, or figure B is congruent to figure A. The transitive property of congruence says that figure A is congruent to figure B and figure B is congruent to figure C. I can skip over it and say figure A is congruent to figure C. So let's take a look at another example. I have this segment here. This whole distance is 4x minus 4. From n to m, it's 2x, and from m to o, it's 3x minus 9. So the first thing I'm going to do is to set up an equation using the segment addition postulate. Remember that the two pieces have to add up to the whole. So 2x plus 3x minus 9 equals 4x minus 4. Then I can just simplify. I can combine like terms. That's also simplifying. And I get 5x minus 9 equals 4x minus 4. I have more x's on the left, so I'm going to take away 4x from both sides using the subtraction property of equality. Then I'm going to use the addition property of equality to add 9 to both sides, and I get x equals 5. In example 3, and if you're doing the fill-in-the-blank notes, I accidentally had the wrong thing here, so please change that to the problem. So we're going to solve for x. We have this drawing here, and it shows how big angle ABD is, and how big angle DBC is, and how big the whole angle is. So the first thing I'm going to do is use the angle addition postulate to set up a relationship between these three things: 3x plus 5, 6x minus 16, and 8x. So this angle right here plus, let me go ahead and get a highlighter, plus this angle right here has to equal the whole. And I'll change the ink color. There we go. So the red and the yellow has to equal that whole angle in orange. So here is my equation. 8x is the whole, equals 3x plus 5 plus 6x minus 16. And that's using the angle addition postulate right here. Okay? Then I can simplify combining my x's, the 3x and the 6x, and the 5 and the negative 16. Now I'm going to subtract 9x from both sides. Now I could have gone the other way and subtracted 8x, but I was trying to keep my steps a little simpler. So I get negative x equals negative 11, using the subtraction property of equality. Then I can divide both sides by negative 1, and I get x equals 11, using the division property of equality. Finally, I want to find the measure of angle ABC, so I'm going to substitute 11 in for 8x, and I get 8 times 11, and my answer is 88 degrees. Now finally, in example 4, these are 4 statements, and we're going to determine which property we can use to justify each statement. First of all, you can see this congruence right here, so I know I need a congruence property. It's the same thing, so that's the reflexive property of congruence. Here, I have measure of angle 1 equals measure of angle 2, so measure of angle 2 equals measure of angle 1. That's just a switch. And the switch is used for the symmetric, oops, that says transitive. It should be symmetric property of equality. So let me go ahead and fix that. Symmetric property of equality when it's a switch. If I had been skipping through, it would have been the transitive. Now let's look at the next one. This one looks more like a skip through. So see how you have AB is congruent to CD and CD is congruent to EF? That means that AB has to be congruent to EF, which is the transitive property of congruence. Notice if I have an equal sign here, it's equal. congruent, 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 congruent. So this one's an equal, so my answer should have an equal. Something equaling itself is the reflexive property. So now we'll leave you with the reflection. When do you think you should use a congruent symbol instead of an equal sign? So hopefully you'll remember that congruence has to do with same size, same shape, usually used for figures. Equals means numbers, values. It could be number of degrees or length, but it's not tied to a particular shape.